1 watt per square metre is very loud. Under optimal conditions, and for some frequencies, humans can hear 1 picowatt per square metre, which is remarkable sensitivity because your ears are probably much smaller than 1 square metre. To cover this huge range, we use a logarithmic scale and units of decibels. The sound intensity level, L sub I, in decibels, is defined as 10 log to base 10 of the ratio of the intensity to a reference level I sub 0, which is usually 1 picowatt per square metre. It's because of the factor 10 that we call the units decibels. Let's work out the difference between the levels of intensities I sub 2 and I sub 1. We substitute, take out the factor 10, and remember that log A minus log B is log A over B. So the difference in decibels between any two intensities is 10 times the log of the ratio of the intensities. Remember that intensity is proportional to pressure squared. So, if we substitute for intensity in terms of pressure, we get this expression. Now, log of A squared is 2 log A. So we see that the difference in level is 20 times the log of the pressure ratio. Sound pressure is readily measured with microphones, whereas sound intensities are difficult to measure directly. So, more commonly, we defined sound pressure level as 20 log to base 10 P over P sub 0 with respect to a reference level of 20 micropascals. Once again, the reference, 20 micropascals, is a value close to the threshold of hearing under optimal conditions and nearly the same as 1 picowatt per square metre. Suppose that we halve the intensity, which means reducing the pressure by √2. How many decibels is that? We substitute, and of course it doesn't matter whether we use the expressions for pressure or intensity, and we get minus 3 dB. In this sound file, we use white noise. White light means an equal mix of visible frequencies. White noise is an equal mix of sound frequencies. Here, the microphone voltage, which is proportional to sound pressure, decreases by √2. So these are each steps of minus 3 dB. Remember the shape of the log function. Log of 1 is 0, so of course two equal intensities have no difference in sound level. As we saw, 3 dB corresponds to a factor of 2. Using base 10, the log of 10 is 1, so a 10-fold increase in power is required to raise the level by 10 decibels. There are more sound file examples and decibel calculations on this link.